Hi friends, welcome to my channel Interesting Engineering. Today in our video we are going to discuss about PMMC Instruments. What's meant by PMMC? PMMC is nothing but Permanent Magnet Moving Coil Instruments. It's otherwise called a D'Arsonval instrument because its operating principle, working, construction, everything is almost similar to that of a D'Arsonval meter. It works on the principle of Faraday's laws of electromagnetic induction. This is an instrument meant for measuring DC values of voltages and currents. So let's see about its construction. So I have given about the construction in 5 main parts. So any PMMC instrument consists of these 5 main parts: permanent magnets, moving system, controlling system, damping system and the display system. Let's compare this with our diagram. So here when we look at the diagram of a PMMC instrument, it's almost similar to that of a D'Arsonval galvanometer. So here we have a center core, so that is made of aluminium, and this core is surrounded by copper coils. So this copper coils, number of turns in copper coil differs based on the value that's going to be measured. For when it is used as an ammeter, when it is used for measuring the values of current, the number of turns in the copper coil will be less, and when it is meant for measuring voltage values, the number of turns will be increased. So here this acts as the moving system, and this moving system is placed in between the pole pieces of magnet. The permanent magnet used here is made of materials such as alnico and alcomax. These permanent magnets provide a magnetic field of high intensity, and this entire system is suspended at the top by means of a phosphobronze wire, and at the bottom it's suspended through a spring arrangement, and it is connected with a pivot and jewel bearing. So this spring arrangement acts as a controlling system here. Why it is controlling is, it's because that develops some sort of force in the moving system, and creates some sort of deflection in the moving system when the current or voltage that is to be measured enters into the moving coil arrangement. So this movement is being controlled by means of the force developed by the spring in the opposite direction. So that's why it's called a controlling system. Here we have one more system called the damping system. Damping is nothing but when the system oscillates, when the system operates, when we pass current or voltage to be measured into the moving coil arrangement, the coil will be deflecting. So due to its deflection, the pointer will be oscillating in the scale arrangement. So that oscillation has to be controlled and has to be rejected, neglected, so that it remains in a steady position. So to have that damping, we make use of a damping arrangement here. So the damping arrangement we made use of is the aluminium former placed in the field of permanent magnet. And the last system is the pointer and scale arrangement, indicating system. So in the indicating system we have a pointer and scale arrangement. In PMMC instruments, the scale used here is uniform. Uniform in the sense it will have equal number of divisions, and there is a provision of mirror in the pointer and scale arrangement. This is meant for eliminating the parallax error. So this is about the construction, and now let's see about its working. So the working of a PMMC instrument is almost similar to the D'Arsonval meter. So here the operation of this PMMC instrument will come across 3 different tasks: deflecting task, controlling task and the damping task. So initially the core is surrounded by copper coil and it is placed in the field of permanent magnet. So when we pass current through the coil, the coil will be experiencing some sort of force. So that force is due to the interaction of magnetic field provided by the permanent magnet and that of the field developed due to the passage of current into the moving coil arrangement. So that force makes this coil to deflect in a particular direction. So that deflection is called the deflecting torque. So this deflection has to be controlled so that the pointer remains in a steady position. So this controlling is provided by means of the spring arrangement provided at the bottom here. So this spring arrangement produces a force in the opposite direction to the movement of the coil. So whenever take for example, when the coil moves in the clockwise direction, the spring connected at the bottom will produce a force in the anti-clockwise direction. So that force is called the controlling torque. So when these two deflecting and controlling torque balances, this system remains in a steady position. When whatever the force developed in the deflecting in the moving coil system is balanced by the controlling force developed by means of the spring here, was balanced, the coil remains in a steady position. So at that position, the pointer indicates the measurement value. So at the steady position of the moving coil, the indication available at the pointer and scale arrangement will be the representation of the value that we are measuring here. So this is about its working. So let's see about its working in detail here by means of mathematical equations. Whatever I have explained there, I have given here. When a current carrying coil is placed in a magnetic field, the magnetic field produced by the current interacts with the magnetic field produced by the permanent magnet. Due to this interaction, there develops a torque which deflects the coil, which can be seen by the deflection in pointer. So how can we represent its operation mathematically? At the initial stage, there develops a torque called the deflecting torque and it can be represented as NIBA, where N is nothing but the number of turns of copper coil in the moving system, I is nothing but the current flowing through the coil, B is nothing but the magnetic flux density and A is nothing but the area of the coil. So TD is equal to NIBA. So this deflecting torque has to be balanced by the controlling torque. So what's the controlling torque equation? Controlling torque is represented by TC and it is equal to K into theta. Instead of using theta, I have represented it by means of delta here, but it represents the deflection theta. So TC is nothing but K theta. So K is nothing but the string stiffness and here delta, which is nothing but theta, is the angle of deflection of moving coil. So when these two torques are balanced, the system remains in a steady position. So TD is equal to TC. When we substitute the values of TD and TC here, TD is nothing but NIBA and TC is nothing but K into theta. So NIBA is equal to K theta. When we look at our equation, the terms N, B, A, these are all constants. So I am replacing it by a single constant G. So G into I is equal to K into theta. We need the value of current. So when we bring all other terms to the other side, we have it as K by G into theta. So this is a PMMC instrument torque equation. So therefore the current through the instrument is directly proportional to the deflection of the moving coil. So now let's see about the advantages and drawbacks of using this PMMC instrument. The major advantage of using this instrument is we can have a accurate measurement when we make use of this PMMC instrument for measuring the electrical quantities. And it is provided with a uniform scale arrangement, that is the divisions are linear, and we have we need a little amount of power to operate this PMMC instruments. So these are all the advantages of PMMC instruments. Next comes the drawbacks, disadvantages of PMMC instrument. The first main drawback is it can be used only for DC measurement purposes. When we use it for AC measurement values, at the positive half cycle there develops a deflecting torque which will be balanced, which will be equated to the torque developed in the negative half cycle of measurement. So the resulting torque will be 0. That's why it is not used for AC values of measurement. And the cost of the instrument is also high in the case of PMMC instruments. So this is about the PMMC instruments, and in our next video we shall discuss about MI instruments, moving iron instruments. So thanks for watching. Please subscribe and share and keep watching for more videos.